You're all very, very welcome to this carrotfly webinar, which has been organised by the Teagasc Horticultural Development Department. My name is Andy Welton, and I'm your MC for the next hour or so. But my co-host is Owen Sweetnam. Owen is recently joined Teagasc. He replaced Stephen Alexander, who I know most of you would have known over many, many years. Stephen retired late last year, and Owen has taken over, and he is now our vegetable specialist based in Ashtown in Dublin, covering the eastern region. We'd like your participation in a small online poll, and I'm going to ask Owen if he'd like to just introduce that and carry out that before we'll have our presentations. Thanks, Owen.
Thanks, Andy. Good evening, everybody. So I'm just going to launch the poll here. It's just 3 short questions. So the poll should be on your screen there now. And the first question is, what is your preferred insecticide program for carrotfly control? You should be able to tick one of the 3 options here. The first option is the sequential use of pyrethroids, such as karate and desis. The second option is the sequential use of karate with coragen. And the third option is Benevia. The second question is, when do you stop spraying for carrotfly? And the options are early September, mid-September, late September, early October, or mid-October. The third question is, would you consider using fly trapping and or weather data prediction models to provide more targeted and improved control programs? And you've yes, no, or undecided. So we'll just give you a minute now or so just to put your answers in there, whatever you think. So question 1, possibly a bit of a surprise there, I'd say, Andy, that sequential use of karate with coragen is the most popular, slightly ahead of the karate desis option, and 10% of participants said they use Benevia. Question 2, when do you stop spraying for carrotfly? The seems to be mid-September, late September, early October, but late September is the most popular. And question 3, when or would you consider using fly trapping and or weather data prediction models to provide more targeted and improved control programs? And overwhelmingly everybody said, or nearly everybody, 82% of attendees said they would consider it, and only 2% said no. Okay, so I'll stop sharing results and hand you back to Andy to continue on.
Great stuff. Thanks everybody for engaging there. That's fantastic. That's very, very useful, I think, for both our presenters. It might just put things in context a little bit as to the way people are thinking this side of the Irish Sea. So look, without any further ado, can I introduce our first presenter, Professor Rosemary Collier. Rosemary, ladies and gentlemen, trained as an entomologist and has worked on pest insects of horticultural crops for years. She's given a lifetime as research on horticultural pests, with her main interest now in the development of application of integrated pest management strategies for horticultural crops, particularly field vegetables. She's a member of the Royal Horticultural Society Science Committee. She's chair of the UK Insecticide Resistance Action Group, and she's coordinator of the IPM working group for the European Vegetable Research Institutes Network. So there's a fairly good CV, Rosemary. Thank you very, very much for joining us tonight. We're delighted to have you, and we look forward to your presentations.
So I'm going to talk, as Andy said, about some of the research that we've done on carrotfly over the years, and much of it is based on things that we've done at Wellesbourne in Warwickshire in the UK, where I'm based. Just trying to do the next slide. Right. So in case we've all forgotten what we're talking about, then I thought I'd just give you a few images of carrotfly. So an adult fly, a large larva emerging from a carrot root, some carrot flies on sticky trap, and then on the left-hand side, some carrots heavily damaged by carrot fly, and they were attacked when they were very young, and as a result, carrot fly killed quite a number of the carrots. And then on the right is the damage that you would more typically see as a result of second generation carrot fly, when the roots are fairly substantial and they burrow into the roots and make the mines. So here is a typical example of our carrot fly trap captures at Wellesbourne. This is 2019. We have very large numbers of carrot fly at Wellesbourne because we grow carrots without insecticides all year round, to ensure that we do have a population for experimental work. So in some ways it's atypical because they're so abundant. And here you can see the usual pattern of fly activity for the middle of England. So three generations: first generation, second generation, third generation. And you can see here the black bars are the flies emerging from the overwintering carrots, and then we move our traps into the new crop for the year. So I thought I'd base my talk around the integrated pest management pyramid, which is quite a popular way of talking about IPM. And the idea behind the pyramid is that you start at the bottom of the pyramid when you're planning your pest management strategy. And so you start with thinking about various agronomic practices such as crop rotation, resistant varieties. And then you go on to look at your decision support tools. So you might use traps to monitor, forecasting system. And then if you have got a problem, or you perceive there's going to be a problem, then you might use some form of physical or natural control, and crop covers would be an example of that. There might also be biological controls that you could use. And then only if you still perceive that you have a problem would you actually use chemical control. And another way of describing it is in terms of the different layers, so prevention, detection, and then control. So I'm going to start at the bottom of the pyramid and talk about a couple of agronomic approaches, and one that I think is by far the best way of managing carrot fly, if you can, is crop rotation and isolation. And so the basic idea is that you isolate your new crops from your old crops to reduce the chances of the carrot fly finding your new crops. And this is an overview of an experiment we did at Wellesbourne quite a few years ago. Here's the source of our carrot fly, so where we keep our carrot fly population. And in that year, we sowed 11 plots of carrots at different distances from the source of the carrot fly. And then we recorded the numbers of flies, eggs, pupae in the soil, and then the amount of root damage in all those plots. And we got this, at the time, quite surprising relationship. You just need to remember that both the axes on this graph are on a logarithmic scale. So 1, 10, 100, 1,000, 10,000. You've got the distance from the emergent site, the overwintering site, because it was first generation carrot fly, along the bottom axis. And then you've got either the numbers of flies captured on sticky traps or the percentage of roots damaged when we sampled roots from the plot. And you see for both of them, there's quite a good straight line relationship, indicating quite clearly that the further away your new carrots are from your old carrots, the less your risk of getting carrot fly. And there's at least a suggestion here that you need to separate your old and new crops by at least a kilometre. And just the illustration, the plot on the left, which you've seen already, this was close to the source of carrot fly, and the one on the right was about 1 kilometre away, and you can see no obvious signs of damage. Another cultural approach, which is possible to use at some times of the year, is actually to sow your carrots late to avoid the first generation of carrot fly, to avoid them laying eggs. I realise that with continuity of supply, it's not possible to do this for all your crops, but definitely probably for some. And again, this is an experiment we did at Wellesbourne, where we sowed small plots again at 2-week intervals from the middle of March to the middle of June. And then we allowed the natural population of carrot fly to lay their eggs on the plots. And then we covered the plots just before the beginning of the second generation with fine mesh netting, put some traps in there, and then we counted the numbers of flies that came out. So the second generation flies that came out. And you can see that for all the sowing dates, if you like, before the start of the first generation, then large numbers of flies emerged. So we were perpetuating the population. But for the plots that were sown from about the middle of May onwards, then the numbers of carrot fly in those plots were very low. And that's just basically because when those carrot flies came out, there wasn't anything much for them to lay eggs on, or nothing at all in the June option. So again, another approach that you can use. So now I'm going to move up a layer in the pyramid and just talk a bit about detection, about decision support. And obviously you can use sticky traps to monitor carrot fly, and I've already showed you that we use these quite often, and we use them mainly just to see what's going on and to also check out that our carrot fly forecast is okay. And this graph again shows you the same data I showed you at the beginning, but this time I've put on top of it the carrot fly forecast. So this is our forecasting model. It uses soil and air temperatures from the 1st of February, and you can use it to predict carrot fly emergence and carrot fly egg laying. And at the moment in the UK, the output from the model is posted in the AHDB Pest Bulletin on the Syngenta website, and I run the model for about 10 different sites from Scotland in the north to Cornwall in the south. And I think Colin will talk some more about timing, but from my sort of experience, the greatest value from that forecast has been in timing the start of treatments, and particularly the pyrethroids, when we were completely reliant on those. So timing the start of the application, because we've known for a long time that the pyrethroids that are applied as foliar sprays, they only kill adult flies. They don't kill the larvae in the soil or the eggs. So you need to get your first spray on before they've started to lay significant numbers of eggs. So obviously our climate's changing, and I've been thinking quite a lot about what will happen to carrot fly in a warmer climate. And one way to I guess sort of estimate what might happen is to look at carrot fly activity in a warmer place. And this is a graph based on some information from a colleague, Francois Villeneuve, from southwest France. And as you can see, there are 2 peaks and a gap in the middle. And what they believe is happening is, because it's warmer there and very warm in the summer, that the carrot fly actually become dormant for a period while it's warm in the pupal stage, and that's called estivation. So they just stay dormant in the middle of the summer, and then when it cools down, they emerge. So although it's sort of at the same time as our 3rd generation would be, it's actually the 2nd generation. And it looks as if something like that might be starting to happen in the UK. And we've noticed in some years at Wellesbourne that the 2nd generation seems to sort of disappear a bit. And then we get a sort of larger peak at the time of the 3rd generation. And that peak may be some 3rd generation flies and also some estivating 2nd generation flies. And so I think my question is, will that second generation, third generation egg laying become more important in the future? We did a bit of work 20 years ago to find out when we thought people should stop spraying, and at that time the last new larvae of the year were found at the end of September, which seems to tie in with the dates that you're stopping spraying, but we have to keep our eye on that in case it changes. So back to my IPM pyramid again, and now I'm going to go to the top of the pyramid and talk about insecticides. And obviously, I guess we've all been very reliant on pyrethroids, probably for more than 20 years. And that has been of some concern, and people have thought, you know, maybe resistance to pyrethroids might develop during that length of time. So we've done a lot of work on insecticidal control of carrot fly. And when we started doing that work, it was on hallmark, which you call karate, lambda cyhalothrin. And more recently, we've been working on new products, and I'm going to talk about them a bit later on. But in all our trials, we've always had a control treatment with no insecticide to see how the damage would be if we applied no treatments at all. And then we've also had what we call a positive control treatment, which is a very intensive, or what we think is very intensive program of pyrethroid sprays. And that's just to, if you like, see what the best scenario might be, and comparison with new treatments. So this is an example of our standard program. So we would apply the first treatment when our carrot fly forecast says that 10% of flies are emerging, so the start of emergence. And then we would apply the pyrethroids at 2 weekly intervals, and we would actually go on longer than I think we actually need to, but say this is for a positive control. And I just wanted to show you this graph. So this is the data from the untreated control and the positive control from 16 years of trials. And you can see that all the points lie along a curve. So this is showing you the relationship between, if you have that much damage on an untreated plot, what a hallmark program is likely to do. And it's not unexpected that it's a curve, but the interesting thing is that all the points do broadly lie on the curve, and there's no evidence yet of resistance developing, at least at Wellesbourne. So now I'm going to talk about some of the more novel treatments, and I'm going to start with Coragen, chlorantraniliprole. And here, what we have done is, and you're looking this time at percent undamaged roots. So the higher the bars are, the better it is. And we compared 3 timings of Coragen applications with hallmark program and the untreated control. And 0 here means that the treatment was applied when 10% of the second generation was forecast to emerge. So we've got here Coragen applied at 10% emergence, Coragen applied 1 week before 10% emergence was predicted, and then 3 weeks after 10% emergence, and then 0 and 2. And from this, you can see that the most effective treatment, whether that's a statistically significant difference or not between that and the hallmark, I don't know, was from Coragen applied at 0 and 2 weeks after 10% emergence. We actually done more work on Benevia, cyanotraniliprole, and that has been a lot of work for DuPont, who originally developed this product, and then it was recently passed to FMC. Again, this is the results from a similar sort of trial, but with more treatments. So here we've got Benevia applied 0 and 2, 0 and 4, 0 and 6. And that's 2 treatments of Benevia, and then we've got 3 well, they're not programs, 3 single treatments of Benevia at 10% emergence, a week before 10%, 2 weeks before 10%, and then the Hallmark program and the untreated. And again, you can see that the Benevia 0 and 2 weeks is the most effective treatment, but actually all of the treatments, and including these single sprays applied in advance of the carrotfly 2nd generation, are also pretty effective as well. And that is the very interesting thing about Benevia. And here's another trial again for DuPont, where we were asking the question, what happens if you apply Benevia quite a long way in advance of the start of the 2nd generation of carrotfly? And you might want to do that if you were also going to try and get some benefit in terms of control of aphids on the crop. And again, these were just single sprays, and again, compared with the untreated, you can see a good level of carrotfly control, with the 0 weeks being the most effective. But again, there isn't a significant difference, say, for example, between those two. So again, showing sort of great persistence of activity. So we tried to understand a bit how cyantriliprole, how Benevia is working. So one of my colleagues, Andy Jukes, he did a small trial where he covered carrots with fleece to keep out the natural carrotfly, and then he inoculated them with carrotfly eggs either before or after spraying. And then some of the carrots were sprayed by targeting the foliage and covering the soil around them so that the spray only went on the foliage, and some of them were aimed at the soil. And what he found was that there was control. This is the number of carrotfly mines, the number of holes per plot, and there was control from either approach, but the control levels were similar for both application methods. So we still don't know sort of for sure how much activity there is against larvae, although in the next trial here, I'll show you there is definitely activity against the flies, as there is with karate. And in this trial, basically, carrot plants, so this was in the laboratory, carrot plants were sprayed, and then they were put into cages containing adult carrot flies at different times after spraying. So the carrot flies were exposed to residues of different ages in different cages, and that showed that Benevia was very effective at killing the adult flies for at least 8 days, and there was some control for more than 4 weeks. So although we don't have any data on how this actually affects egg laying, it does support the results from the field trials, which indicate this prolonged control with a single application. And in terms of insecticides, I just wanted to say a bit at the end about aphid control. In the UK at the moment, I think aphids are actually of more concern than carrotfly, and that's due to virus transmission, and that's related to the loss of the neonicotinoid seed treatment, which was quite effective in controlling aphids on carrot. And again, this was work with DuPont, and they wanted to kind of see whether or how Benevia might be deployed against both aphids and carrotfly, maybe. So this was a trial aimed at the willow carrot aphid, and sprays were applied on 2 occasions when aphids were on the plants. And this is just to point out that both Benevia and Movento killed the aphids. Hallmark did nothing, and that's because our willow carrot aphids are resistant to pyrethroids. And then what happened in this trial was that it was then left in the ground, and then carrot fly damage was assessed on the 14th of November, just to see if there was any effect from those fairly early sprays of Benevia. And as you can see here, there was. So this is the percentage undamaged roots. And you can see that Benevia, although it probably wasn't a high enough level of control for the market, it did actually reduce carrotfly damage. And then there is quite complicated trial here, again, which was about looking at the potential for, well, at when one might deploy Benevia. And so there were a number of treatments. So untreated, that's Cruiser, the seed treatment. Then we've got sprays targeted against aphids, and those were applied on the 25th of May. Or the standard one, A0, was applied on the 25th of May. And then we had sprays that were applied 2 weeks before that, or 1 week before that, and then 2 weeks after that, just to look at the different effects of timing. And then there were a couple of treatments that then received subsequent applications for carrotfly as well, as did the Cruiser treatment. So you can see in terms of aphid control, this is the number of aphids on the plants that basically A plus 2 or AO, so getting the timing spot on was better than applying the sprays too early, so not much persistence indicated in terms of aphid control. And then if you look at the carrotfly down here, then this treatment had the Benevia spray for aphids and then an additional Benevia spray for carrotfly on the 31st of July, and that provided the best level of control. But again, this treatment, the Cruiser one, had additional hallmark sprays, as did the Biscaya. But these Benevia only treatments targeted against aphids still provided a degree of carrotfly control. So back to my pyramid again, and I'm just going to say a couple more things about it. What I haven't talked about are the physical control, and of course that could be netting or vertical fences, and like I say, I think Colin's going to talk about those. In terms of biological control, then there has been some research, but nothing's been found that's either very effective or economically viable yet. So when you're talking about putting different treatments together for carrotfly control to maybe reduce the reliance on insecticides, then one way of thinking about it is to look at what sort of impact you might get from these different approaches. And so these are some estimates compared with a high-risk site, which might get, say, 15% damage if no control methods were applied. And these are what people in various projects have estimated to be the impact of different approaches. So, for example, the type of resistant variety that you might be able to use at the moment might reduce damage by up to 50% compared with the susceptible variety. And obviously, if you used a crop cover and you used it properly, then you'd get no damage at all. And just to show you, this is pictorially how these different treatments might lie. And in there, I've also put in insecticide that might be 70% efficient and one that might be 90% efficient. Again, you've got your high-risk site with a estimated 15% damage. And you can see a whole range of different levels of control by doing different things. And then what you can go on to is look at different combinations of those approaches to see how much you can reduce damage by combining certain approaches. And again, I'm not going to go into the detail here, but it is a good approach to start thinking about how you might reduce your the size of your infestation and reduce your reliance on insecticides. So I'm going to stop there. So thank you all for listening, and thank you to the organisations that have allowed me to use the data and funded the work. The pyramid came from an EU project I'm involved in called Smart Protect. And then thank you most of all to those who do the work, the field work, so Andy and Marion and our horticultural services team at Wellesbourne. So thank you.
Thanks for that, Rosemary. Fantastic overview, an awful lot of information. I was just thinking there, you know, we'll have to sit down and study a lot of the graphs in a lot more detail to really get what a lot of it is saying to us. And just to say on that point that, look, the presentations, ladies and gentlemen, will be put up on our website in the next few days, so you'll have time to maybe take the slides and the information and read it through and digest it in your own time, because there is an awful lot of information on there. A lot of it very basic. I guess we're going back to basic agronomy when it comes to the, you know, meeting some of our obligations under the whole business of IPM and the Sustainable Use Directive, which we have to be very, very mindful and conscious of now and going forward. And you've touched on an awful lot of that, Rosemary. And what's encouraging, I think, is the work you've done on Benevia. It's great to know that there's going to be choice there going forward. You know, we do know that the pyrethroid programs are coming under pressure. That sort of chemistry is coming under pressure going forward. So look, it's good to know that there's encouraging results from the trials, and that we're going to have some options, albeit they may be expensive. There is one or two questions, Rosemary. I'm going to kick off and maybe ask you the first one that's come in. Can relying on DSS, Decision Support System, cause you to be too late anyway, due to being up to a week late waiting on a threshold?
Well, I guess that's the difference between using a forecast and using traps to monitor. So obviously with traps, how soon you get the information to a certain extent depends how often you visit your traps. The idea behind the forecast is that you get advance warning, and as you get closer to the event, you get, I guess, more accurate